So part 2 here. So we know what a correlation is. You've always heard the statement, going down in your notes, that correlations are not what? You can't say that correlations are causation. And you already kind of hit some of the key details. Because you're not manipulating variables, it's very difficult to assert cause and effect. You're not manipulating variables, so it's very difficult to assert cause and effect. That's why in psychology, we like to do manipulated studies, because then you can make more cause-effect conclusions. And I want to give you 3 examples, maybe 2. A couple of examples on why correlation is not causation. So the examples are also, a couple of these are in the book as well. Let's start actually with the first one. Are any of you aware that there have been studies that have looked at how much violence kids watch on TV, and then do these kids become what? Violent themselves. Have you seen some of these studies? So there is psych research out there that you're probably familiar with, and the thing you want to write down is there is research that shows that when you do a study and you ask the kids, well, how much violent TV do you watch? And the more violent TV they watch, the more aggressive they tend to be, the more violent they tend to be. Both of those variables are continuous, so what's the right stat? A correlation, once again, if they're both continuous. So a researcher would like to assert that what causes what there? Yeah, you'd like to make the assertion that TV causes violent behavior. But why can't you do that?
Maybe they're naturally inclined to be violent or aggressive, and that's why they choose to watch them.
So there's a problem with what's called, you're exactly correct, directionality. Is it that TV causes the behavior, or that these people are naturally aggressive and violent to begin with, and they just like doing what? Watching violent TV. Is it A causing B, or is it B causing A? When you do a correlation, you don't know. So you can't say this causes that. It's just not appropriate. God bless you. So that's example number 1. Example number 2. Your book has a fun time with example number 2. It's in the correlation chapter of your book. Studies have looked at, and very interesting, they find that they look at the number of churches per geographical area, and the book cites statistics that actually show the more churches that are in a given area, the higher the crime rate. It's a true statistic. The more churches per given area, the higher the crime rate. So you can write that one down. The more churches per given area, the higher the crime rate. Studies have actually shown this. So would you like to assert that churches cause crime?
No, not. I would like to know, though, is it per capita or just mileage?
I think it's mileage.
You would imagine, though, like in an inner city, because there's so many people, there'd be more churches and also more crime and more people.
So there's a third variable there. So you're exactly correct in the evaluation here. This is the classic case of a third variable. No one would like to assert that churches cause crime.
Okay, small, medium, and large cities.
Yeah, it's small, medium, and large cities. So the bigger the city, the more crime and the more churches there actually are there. But the issue here is there are more churches per given area in the bigger cities. So the third variable here is basically there are more churches in larger cities. So it's the fact that you're in the inner city. Inner cities are well known to have higher crime rates. So you have to be careful in saying that these two things are causal, because many times there could be a third variable involved. And that's the case on a lot of correlations. You never really know because you can't control those variables. So
Is there a way to go back and test the same way you do with the post hoc tests? Can you do that with these tests and find out?
yes, the answer actually, it's a good question. Can you actually go out and somehow look at that? Your book also takes some time to point out that what you can actually do if you're concerned about third variables like this. It's not really a post hoc test, but you can run what we call a partial correlation. You can kind of take that piece of the puzzle out. You can look at how the geographical area, the size of the area is involved, and you can correlate that with what you want, and then just look separately at the relationship you care about. It's called a partial correlation. So you can actually factor those things out a bit. That's a good question. Other questions? Let me give you one other situation that used to make a lot of sense. Doesn't quite work as well these days, but as a psych example. Back in the early 80s, there was a group, actually the group is still around. Or is anybody familiar with the Church of Scientology? You know what the Church of Scientology believes in terms of medicines being used for mental health?
They are not in favor.
They are not in favor that medicine should be used for any sort of mental health situation. And in the early 1980s, they found 5 people or so who were taking Prozac. And it turns out that these 5 people were taking Prozac, and it turned out that at the same time, these people were also suicidal. And so they wished to assert what? That Prozac causes suicide. These 5 people were on Prozac and they were suicidal. It was part of, one of their campaigns to say, look, these drugs aren't good. Obviously now there seems to be a bit of a turn in the tide for that one, especially for younger children. But they were going on all these talk shows saying, look, this shows that this causes suicide. Would there be anything wrong with making that argument? Very small sample size, number one. What if we asked how these people were before the Prozac?
There was a reason why they were given
Turns out that all 5 people were suicidal before Prozac. So if you have something that's already there beforehand, if people are suicidal before a product and then they're put on a product and they're still suicidal, don't assume causality. The fourth and final reason, and your book talks about this as well, outliers. So if you look back at this scatter plot, you see the scatter plot here? If you have 5 data points like this, but let's say there's a 6th data point in here, and let's say that it's really, really extreme, an outlier could really throw off the whole data set. This isn't a logic argument, but if you've got something that's, all your data is right here, and then you got one point way above and beyond, it could really skew your data set. So you have to be careful for outliers. So we have to be really careful about saying that correlations are causation. Comments or questions about this one? This was a little easier than the previous little ditty. Should we stop this one? Okay.